Because we're in the same like.
Okay, so the bonus points are going to be in the lab assignment group, which is 70%. Okay, taking 70% of the overall grade. 60%, I think. 60%. Now it's starting at 70% since we don't have the final exam in yet. So eventually, if you don't do well in the final, you're expecting your grade to go lower as well. Again, at the end of the semester. But however, now your lab, because you are getting pretty good grade from the lab and in labs, right? So it's taking, now I use 70% instead of 60%. But actually in the syllabus, that's through the communication between you and me a few weeks ago, right? So we all agree on that. So labs and in labs and homework assignments and everything is 60%, right? And we got the exam one, a lot of you didn't do well. But anyway, so exam one is only taking 10%, right? That's the exam one. This is in lab and lab. It's in the syllabus. You can check that out later. And 10% for the final. That's pretty nice for you guys. Christmas gift.
Thank you, Professor.
Oh, you need more?
No, it's okay. I like this.
So don't complain, okay? I'm grabbing 20% for the project. That's, you all agree on that, right? So if you don't want to do project, let's move this to here for you, just for you.
Just a 30%.
If you don't like project, let's move this to the final 30%.
Yeah, nothing.
Anyone want it? Just email me, okay? No? Yeah, projects I'll grade it pretty leniently, I think, and as long as you put the efforts. So I'm also planning on building that robot car for you guys, get all the wires, and as an example for you, whoever is working on that ultrasonic sensor thing, so you can use that as an example. And also I will create several PCB tutorials, go through all the details to build a whole PIC board, just reproduce the whole thing that we have been working on the whole semester, so you'll know how to create all the parts, the op-amps and other parts. And final exams will be totally from these papers.
So like
Okay, no mystery. Everything will be from these papers and change the numbers. Okay, so I'm going to give you this kind of practice pretty often, so we can form this kind of feedback mechanism in the future. So I know your names. I'm going to know what you are doing, how you are doing in the class, and give it back to you. And this will be served as bonus points in here. Okay, in here. So how that works is like you have like, for example, lab 1, 100 points, right? If you earn 100 points, then it's 100%. Okay, so for lab 2, it's 100 points for the denominator, and then you learn like 90%. That's why you are not getting 100%, right? But now, for the actual bonus points, okay, I'm getting 0 here, but if you are learning like 30 points, so it's getting boosted. Make sense? That's how that bonus points works. So if you see that you're getting 30 points for the bonus point, but your grade went down, why? It's because I just adjusted the percentage over here. That's what is written in the syllabus. This was 90%. This was 90%. Sorry, I just ignored it. I don't know, like probably I did it, but I couldn't remember when I did it. Since we don't have anything came in, so that's why we only had this and this. So I was setting up this as 90% as 10%. That's why your grade was pretty good. But now you see a lower grade, but eventually if you attend class and do all the papers, your grade should go up because of this. Make sense? Okay, let's do it. So first, I want to introduce the thing for lab 8. So lab 8, don't get nervous on it because I'm going to show you pretty much everything about the code, but in a different way. Since I don't want to disclose the code in a way that I can directly duplicate, but it's almost the same stuff to help you understand what's really going on. Okay. So first, I think we should talk about the sample intervals, because a lot of students are doing frequency measurement. So let me ask you one question. If I'm telling you this is 20, I put a number there, okay, it's 25 microseconds. But in C, I did a unsigned, right, like this. 25. It's just 25. It's not 25 microseconds. It's 25. I put a number there, right? So what's the sampling frequency number you can use? What's the sampling frequency? Sampling Sampling frequency. How do you represent the sampling frequency? Use numbers in C. If I just give you 25, it's actually sampling at 25 microseconds, but we know it in our brain. But the PIC doesn't know it. You just put a number, it's just a byte. How do you use that as a frequency? Sampling frequency. What does that mean, sampling frequency? It's samples per what? Per second, right? Okay? How to represent it? If I put a number 25 in there, how to convert it to how many samples per second?
1 over 25.
Just 1 over 25 times 10 to the negative 6 now.
Yes? So basically it's 10 to the 6 over 25. Or you use this. Okay? But since we don't want to mess with this guy in C, right? So what you can do, just use integers. Just directly put this on the top. Okay? And calculate it. What is the sampling frequency though? Is that 40K?
I don't think so.
40K samples, 40K hertz. Okay? So one thing, because I was thinking about it, how you guys can master this kind of calculation in the future during the exam. So I have to go through this through your mind entirely. For this kind of frequency measurement, what do you need to know? Remember this, okay? Number of intervals per what? Per second divided by number of intervals per period. I'll show you why we wanted these two numbers. So this divided by this is getting you what? So what are the intervals? This is the interval, time interval. You're sampling at average 25 microseconds, so this is 25 microseconds, right? For example. Okay? So the number of intervals per second. How long is this? This is the period. You don't know how many intervals yet. But for a second, you are having a lot of sine waves. It's gonna be a lot. For example, this is a second, right? So you are trying to get how many intervals per second. Okay? This first one you want to calculate. What is it?
Is this how we calculate the frequency for the lab aid?
Oh, the frequency is using the timer. So you set up the interrupt. So whenever you get into interrupt, you sample 1. So you know the frequency because you know the interrupt
What are you
time.
calculating here?
How to calculate here? I'm calculating the frequency for the frequency measurement.
Okay.
Yeah, we'll get into there really quick. So take a look at this first. So number of intervals per second. What is this?
40,000.
Yes, we just covered it, right? Done. What about this? It requires some calculation in the C, right? After we get a signal stored in the array, we need some kind of signal processing work. Okay? So let's put this away for now. But however, if I do this division, okay? So let's see. Number of intervals, okay? Per second divided by number of intervals per period. Okay? Cancelled. Flip to the top.
Gives it periods per second.
What is this?
Frequency.
Yeah, it's a frequency. Frequency of what? The sine wave. You agree with that? This is 1 period, 2 period. How many periods per second? Which is the frequency of this sine wave? That's what we want. So this is already known. We can set it up in the timer. We just need to get this one, okay? How to get this? So for example, you get this, okay? Eventually, this is what you sampled.
You just
All
don't
right.
know how long the period is.
Count the periods. How many intervals in one period?
Mm-hmm.
You just need to know how long the period is because you know how long you set up your
Yeah. Let's use a zero crossing technique
Yeah.
over here. Whenever the index I is lower than the threshold, and index I plus 1 is higher than the threshold, it's an easy if statement. I'm going to show you the code today, even though did I print it out? No, but I'm going to show you it's recorded. Okay. So if one point is lower and the second point is higher, it's crossing, so we record the index. For example, this is the 10th index, 10th number in the index. It's easy to do because we already use the interrupt. Whenever the flag is on, the interrupt will do all the sampling, will store 250 points into the array. It's already there, it's ready. It's ready for you to process. Okay? This is what's in the array. You take it out, put it in the main file, and use the for loop to go through every single thing, and use the if statement to take out every zero cross detected. Zero cross detected, record index. Okay? Zero cross or not? No, because the previous one is higher, the next one is lower. It doesn't satisfy the if statement. So it's if the current one is lower and next one is higher, it's a zero cross going up. Okay?
And one of those has to be lower than or equal to, right?
Lower than or equal to, yes. Because the thing is, that's a good question. So why we don't have that issue, I think that's another benefit of using that range in the middle. So we are sampling this guy, right? However, this is 128. Why? Because it's an 8-bit thing. Why is 8-bit? The ADC is a 10-bit. Why is 8-bit? Because we dropped the lower 2 bits. Okay, so many things to talk about. Anyway, don't want to make it so stressful. So we gave up whatever in the middle. Okay. So what we are trying to do is, if the previous one is lower than what, 128, it will. Because the middle point is 128, and we are dropping some points here. So this point has to be lower than 128, and this has to be larger than 128. So we don't have to do the less than equal. Easier. Otherwise, if you have a point directly at here, how do you do it? If statement doesn't work anymore, it's causing issues.
Gotcha.
This is perfect, getting rid of the noise and also getting rid of this issue.
Yeah.
Okay? The data you store in the array is basically just this. Nothing in the middle. All right. Now let's come back to this, okay? Given that we are able to sort this out, okay? Sort this out. So one index recorded, another index recorded or not? No, it's not a zero cross. Is this a zero cross? Yes. I mean, it won't be perfectly like 100 points every cycle because there are errors. Let's say the index number here is 110, 101. About 100 points, okay? 100 points.
Yeah.
That's all the signal I have. That's it. Zero cross or not? Zero cross or not?
Yeah.
Yes. Let's say this, okay? All right? How many periods do I have?
2.
Yeah. But how many points?
3.
How many zero crosses?
3 0.
If I do like a cross count, okay? Cross count as a variable, eventually I count it as 3 because it crosses for 3 times. So how many periods do I have? 2.
Cross count -1.
Yes. It's gonna be on the exam, okay? Cross counts -1. How many points do you have? How many intervals do you have? How many intervals? How do you do it? How many intervals? For example, this is, I have an array to store all the crosses, right?
Yeah.
Okay?
Professor, I saw in your sample code, the code you provided, the cross array does exist. Does that contain, do you put the like indexes of where they cross, or
The indexes and also Yeah, indexes, yes.
So the indexes of where of zero crossings and then
Yeah.
the number of those zero crossings is the cross count amount.
Yes, so basically you have these numbers stored in there, okay?
Yeah.
And because this is in an array, so you know the indexes.
Yeah.
You know how many you have in there.
And then the length of that array is then the number of cross counts.
Mm-hmm, mm-hmm.
Okay.
Yeah. So if we have these ones, right? So it's, these ones access all the numbers in the array. Okay. So I can use what? Cross I plus 1 minus cross I, right?
Yeah.
Plus cross I plus 2 minus cross I plus 1. You can do this in the for loop by implementing this. Okay, so eventually what you're getting, it's going to be 101 minus 10 plus 205 minus what? 101. So this is how many intervals you have. Does that make sense? Because this subtract this, because these are the number of points, number of interval, number of index for the sample points. So here you got a 10th points, and you detect the 10th points is a zero crossing point, and you detect the 101 points is a zero crossing, and 205 is zero crossing. So this minus this is getting how many points, sample points. It's very close to the number of intervals.
And so in the ISR, once you sample the microphone after the threshold is hit, do you and you load those samples into like microphone sample, is that what you're going through?
Yeah, that's array. Yes.
Yeah,
Same.
so that is an array.
Yes.
You can then go through.
Then go back to the main to
and
do this.
Cross values.
Yes.
Like extract.
Yes.
Extract this using and then build the cross array.
Yes.
Okay,
Yes.
so
Build
that
this
is
cross.
an array.
Yes.
It just says a uint, but uint can be anything, right?
What's that?
Is it like a uint can be anything? Like uint 8 can be like an array.
What is a U and A? What does that mean?
Or like when I'm reading the code, it doesn't appear to be declared as an array, but it can be used as.
Yes.
Okay,
Yeah.
that makes sense.
Yeah. So this subtract this is giving you how many sample intervals, and this subtract this is how many intervals here, and you do average. You may have multiple periods. You don't want to just rely on one. So do an average, because these two added together, it's giving you, for example, this is 91 plus 104, right? So eventually you do an average, so it's 91 plus 104 divided by what?
2.
Cross master.
Okay? This is what you are going to do, okay? So what is this giving you? Number of
Intervals
per what?
period.
Make sense?
Yep.
You know both?
Yep.
Frequency measurement for the lab, for the project, done. So since a lot of people are doing the project, so I will just directly run some demos here today to make sure everyone can do it. Make sense? Okay. Let's see what I have for you guys. Don't worry, we have a lot of time left this semester and have a lot of interesting things to cover. So I'll take the time to make sure things are covered. You guys are like, what? Vim?
Not Vim. Not this year.
Why Vim?
Honestly, it wasn't that bad. Using GVim and Vim, it wasn't that bad.
Objectively worse than this.
But it wasn't that bad. Because you never went industry standard Linux, dumbasses. Yeah.
You don't use Linux in your main operating system?
Shut down button instead of typing a 300.
You do because you're iOS. I mean, yeah. Because iOS is
It's
a Linux-based.
Unix-based.
Yeah, it's a Linux-based OS, though.
Is that visible?
Yeah.
Sort of. Okay, I have several tasks for you guys. I have to comment this out first. So before I do that, I want to highlight this too because you guys will start making notes, okay? And turn it in after. Just pass it to the back. Probably not evenly distributed, just pass it around. These two.
Go back of your bag, yeah.
Pass it back.
Oh, yeah.
This whole thing. I was like, please, I'm begging. Literally.
So for the first paragraph of the code, take a look at it. It's part of the Lab A stuff. Or I think it's Lab A, yeah. It's a very simple for loop. Can anyone on the back see it? Okay, so no magic here, but look at this one. What is this doing?
It's bitwise ending it with a bunch of ones.
Yes, but what is this doing?
Checking if the lower nibble
Yes.
equal to 0.
Yes, but what? But why? I mean, take a look at the print function here. Okay, it's problem 1 on the in-class exercise. Okay, take a look at it. So what is this number here, basically? 15. Okay, so it's ending with 15. Whenever this equals to 0, what does that mean? So I already getting incremented by 15 times, right?
That means it's equal to.
So cycles every 16 times.
Yeah.
So every 16 times is getting to the print function and do what? Print something.
Yeah.
So it's basically printing a line number there. So you are printing out how many numbers? 256 numbers. Why? Because the IC here is cycling from 0 to 256. So it's printing out the current number, the current index. So no magic there. It's just printing out 0 to 256. However, if you have all the numbers, you can line it in a column. What's that?
What is %2D?
Percent 2D is the 2 positions, 2 digits, and it's a decimal.
Oh, okay. And it's putting it inside those brackets because that's where the format is, or?
Inside it's putting this current index into here. So it's a bracket, just a bracket, and S is just a S. It's just a letter.
Yeah,
What's
so
that?
it's like sample app.
So you
Yeah.
said it goes it increments every 16 cycles?
No, it's incrementing every once, and in here, every 16 cycles, it does a print.
Yeah, okay.
But however, the for loop is printing. Oh, sorry, I was wrong. So actually, it's every 16 numbers, it's printing out the index. But however, it's printing out the same thing, which is a character A's ASCII code. It's the same thing. It's getting printed all the time for 256 times. However, every 16 times, it prints out one thing.
Yeah.
It's printing out this thing. So what is this? It's just a letter S with a bracket and with a variable inside. It's a line number. It's dividing 256 A's into 16 lines. So you can see 256 numbers in the array instead of a line, super long line.
Oh,
You know what I mean? So it's, so what's the beginning number of I?
16.
No,
Oh,
zero.
starts at 0.
So 0 and something is still 0, right? So whenever you got 0 at the very beginning, does this one function? Is this one functioning? Yes.
Yeah.
It gets into it and printing out what?
0.
0. 0 put in there. Put in where? In the bracket. So it's gonna print out an S bracket 0. It's a line number. Don't worry about the S. What S means? It's probably serving some of the labs. But just the S bracket 0. It's probably a series of 0. It's like line 0 with how many numbers in the line 0? How many numbers in line 0? 16. From 0 to 15, so 16 numbers. And then you switch to another line. See this?
Yeah. And then you print it.
Wait, where it changed the line?
Slash.
Oh, I didn't. Did I put a line break? So print this one, change the.
So you're using
Let's take a look.
S and I, and then a bunch of whatevers, and then S and I, and a bunch of samples, S and I, and a bunch of samples.
So it's like,
It basically looks like it's 16 arrays out of 16 samples. Why is it printing?
Oh, because I didn't. Oh, I did it. I did compile it, right?
Yeah.
Oh, I didn't save it. Right. You must run. Because my window size, so it's not doing exactly what it's supposed to. It's changing the line here, but the thing is, it's just a one line, right? One line, because you can see it's going to resize, right?
Because there's no slash in it.
Yeah, I can change the font size a little bit to make it looks better. Let's do 24.
Was that intentional, not putting a slash in on the print statement that prints the actual
Yeah, that's
paper?
interesting. Why it's not changing the line here? See, it's printing out. So letter A's ASCII code is 97.
Yeah.
So it's printing out 97. So see here, right? So every time it print out, oh, it's in front of it.
Yeah. But it's printing on a new line after it does that every time. It's just, yeah.
So whenever it reaches that number, it prints this first, and then print out this one. So it's in front of it, so before it. That makes sense. Doesn't matter. So I'm putting this. So are you able to answer question 1 by far? At least you are getting some extra points.
Prints out samples, is that?
It's a line number, right? It's a line number. Line number, and print out the same stuff for all the lines, right? Anyway, so it's recorded, but I don't have internet connection from my lab. I'm gonna fix it. Go to Best Buy after this class. Ooh, life is tough. Got a class at 6, PCB class. Hate my life. Clear on the first one? All right, let's go to the next one. Oh, for the second question, you should be able to answer that. If the ADC samples average 25 microseconds, what's the number of sampling intervals per second?
40K.
Yeah, I already showed you, right? Here. I'll do this really quick since I already covered it. Don't want to take too much time. Okay? And so don't look at this. I'm going to ask you another very simple question. Number of intervals per second is basically what? It's going to be on the exam.
1 divided by x, and then is equal to 25 microseconds.
Yes, but I mean, based on what I just talked about during the beginning of the class, number of intervals per second is basically what?
Frequency.
Very close, combined. What's that? Anyone knows it? Just tell me. Just tell me.
What was the question again?
Number of intervals, number of whatever intervals per second is basically what?
Sample rate?
Sampling frequency, yeah, sampling rate. Okay? If I ask you, what is the sampling rate? Can you answer that?
25.
Same thing. It's the same stuff. See? It's the same stuff. This is my solution. I have keys over here. See? It's the same stuff. Intervals per second, sampling frequency, same thing. Same thing, okay? Next. Given that the number of sampling intervals is sum, for example, we know the number of sampling intervals. Number of intervals is whatever sum. It's a sum variable. I gave it to you in the template. And the number of zero crossing is cross count. Okay? So what's the total number of sampling intervals per second? Yes, cross count minus 1, right? It's the number of sampling intervals divided by cross count minus 1. Make sense? What's that?
Why do we do the -1 again?
Why do we do the minus 1? Because this. You got 3 zero crosses, but only 2 periods.
Oh, okay. Got it.
It's going to be on the final exam for sure. Okay? What is the sine wave frequency if you know the number of sampling intervals per period and the number of sampling intervals per second? The tongue twister.
Yeah. Period over intervals. Yeah.
Yeah. Right? This divided by this, you flip this to the top, you're getting what?
Periods per second.
What is that?
Frequency.
Frequency. Doesn't matter, it's recorded, so you can try to absorb it after class. It's okay, okay? What about SD cards? Haven't covered that yet. All right, hopefully we still have time to do it. Okay, let's do this first. I'm gonna do this really quick, okay? Just directly run it. All right, take a look at this. This is a beautiful sine wave. Okay? I wrote a sine wave generation code here in C to fake it. Okay? Don't worry about this one. This piece of code, just a sine generation. I wrote it. You don't want to put in pick. It's not going to work. It's running on Windows. I know it's a very simple question, but I don't want to see anybody put this code on your Lab 8 report. That's weird. TAs are like, what? Again, it's a sine wave generation just to fake it. Do you have sine waves in your pick? Yes, you just put in an array, put the numbers in the array, and repeat it. That's not that's the way you do it in pick. It's just a sine wave generation. I put frequency here was 2000 frequency, which means 2000 watt per second. 2000 periods per second, which is 2000 hertz, right? 2000 periods per second is 2000 hertz. Make sense? And sampling rate, I'm using 40K. Why 40K? It's the same as what we are using here. Okay? 40K. Just try to mimic everything. So this is going to generate a 2000 hertz and with 40K points per second sine wave. Confirmed. What's the amplitude? 1. I don't have any parameter for the amplitude, just 1. So that's the difference. So for your sine wave, you have what? So for this sine wave, I don't even have, I'm not adding a constant to it. So this sine wave is going to swing around where? 0. It's given, right? Sine waves swing around 0. How do you lift it?
DC offset.
DC offset. How do you add a DC offset?
Just add a value to it.
Just add a constant to it. How do you do it in circuits? In simulation, how do you add a DC offset? Just directly put a DC voltage in series with it. So the DC offset is added to the AC wave. Because DC source is the AC ground. So it's the AC ground, but also it's adding a DC offset. So eventually you are getting the AC signal. Instead of swinging around 0, it's being lifted. Make sense? However, do I have a DC offset adding to this sine wave? No. So swinging around where? 0. So if I'm detecting 0 crossing, I'm actually detecting this. It's going to be different from whatever you are handling, which is swinging around 120A. And then you have a range you are not sampling at all, so you are doing this, right? But this signal in this fake sine wave is swinging around 0 and nothing in the middle is getting canceled. Make sure you understand this. So don't directly duplicate it, but this is very similar to whatever you can use. Just change a bunch of numbers. So basically Lab A is given, okay? Pressure relieved. It's all here. It's going to be posted to my website as long as I fix my laptop. So you want to rely on Best Buy this afternoon, okay?
You don't want to type it out on your phone and post it from there line by line?
Yeah. I mean, cost me $90 to get diagnostics this afternoon.
Really?
Just take a look at it, not even fix it.
Best Buy's such a ripoff.
Oh, you want to Venmo something to me? See here, this is I'm not doing anything else but just calling that sine generation function in main. So what I'm trying to do here. Oh, the sine function is right here. So I don't want to use this one. So I don't have to use this one because I already included in there. So directly have the code here. So if I run it, this main function is going to call this sine wave and do what? Do nothing, but just call it, right? So this sine wave is going to print out all the values because I convert all the numbers of the points into sines value and save it in an array called ADC rating.
Are we gonna do the SD card questions later?
Yeah, later. Yeah. Let's turn it in next time, okay? Since I'm gonna cover the IC part next time. So take it back home, and Wednesday I'll cover the rest of the parts, and then we'll do the rest. You'll turn it in, okay? After. So let's run it. So what's gonna be saved in ADC rating? It's not even ADC rating, just the number of points of the sine wave converted, okay? So it's gonna save all the sine wave points. Let's do it really quick. Oh, I didn't save it.
Yeah.
One more time. Run it. How many points? Yeah, I think I was trying to do 256. Not too much pain by far. It's manageable pain level.
Yes.
Life is hard. My job is to make it harder for you guys.
Graph that.
Woo!
Whoa.
Beautiful.
Would you look at that? It's almost like we coded it.
Then what? I know that works, right? Just to
Use that array, yeah.
what I want to do. What's next? Zero crossing. Right?
Yeah.
So I forgot what I put in example 3, but let's see. So let's take a look at the income source. So print out all the zero crossing indexes. So look at the code here. It's going to be very similar to what you can put in lab 8. Okay. So sine wave generated, and I saved in this array. I'm not going to print out all the sine wave numbers anymore, but I can see how that works. It's like your ISR. You save in the array, and you come back to main. You just go through, access all the points in the array. So that's how you do it. Go to the ADC index, less than 0, the next one larger than 0, then there's a zero crossing. Make sense?
Yeah.
What's next? Just store that index, that current index into it. So these are the indexes like what? Like the 20, the 10, right? 10, 101, 205, these kind of things.
Yeah.
And then you do what? You do, so for this one, we're not doing anything else. Let's run it, save it first. Okay, these are the, what are these numbers? Zero crossing what?
The
Indexes. What's next?
Use,
So this is getting you what?
that's giving you the
Sum.
crossings, yeah.
The total number of what? Intervals.
Yeah.
You do the subtraction. Second one minus the first one, third one minus the second one, so on and so forth. Add all the intervals together, you are getting the total number of intervals.
Yeah.
And then divide by.
Divided by the number of what?
Cross counts by
Number of cross count minus 1. Okay? So now let's do this. Example 4. Save. Take a look.
Yeah.
Sum is what?
Sorry, I don't want
Sure.
to, just too tricky, but, for the math, instead of doing the like second minus first and the third minus second, couldn't you reason that all of them are gonna cancel out, so it would be just the last minus the first?
That could work as well, yes.
Yeah.
In case if they're different.
Try it in pick. Yeah, that makes sense. See, it's the same number here, right? It's 240 minus 20.
It's a total number of intervals.
I think it's trying to get some intermediate values, but go through that.
Yeah, that makes sense.
Yeah, but the thing is that
You don't really need it. You just need the sum.
taking like
That may work.
partial sum,
Yes,
and you get multiple.
because there are zero crossing, and eventually you get a. Yeah, I think that works. Yeah. So see here, average period, average frequency, 2,000 hertz. Did we set up the frequency to be 2,000 hertz?
Yeah.
I fake it as 2,000 hertz, and I detect it. Eventually, it's giving me 2,000 hertz. Perfect. Make sense? I'm going to post this code to the website so you can directly use it for the Lab A. On Wednesday, I'm going to cover more on this bonus points, and eventually I will go through the in-level Lab 9 and also the rest of the Lab A. Okay?
Thank you, Professor Lee.
Sure.
So
Yeah.
Is there any way